Hello everyone. In this video we have see about the X-ray and their crystals. So crystals and X-rays we cannot separate. It will be used for various application. So X-rays we cannot also negligent. It will be used for various application in the real world applications. Where as a medical, whereas a industry, whereas a any other material detections in these. So we will use it for X-rays in various applications. First, it will be inverted by discovered by this William Conrogen. So it got the Nobel Prize for this in the year of 1901. It is the picture left top image of the original laboratory we have who inverted he inverted that is the William Rogen invented X-rays and his laboratory. It is the image that is for the photograph of the William Rogen will be shown in the left top. So that is what is a stature X-rays means X-rays is nothing but the fast moving electrons will be ejected from the source and hitting the heavy element. There is a target element, that is the electron will interact with the inner core of the atom, that is the inner electron, inner circular orbital. Hitting the electron will be ejected or it will be excited to the higher energy state, so that an empty state will be covered by or filled by the moving of external outer orbital electron to the inner core electrons. So that time their energy will be released as the electromagnetic form. That is the one of the best highly energetic ray, that is called as X-ray. We cannot those days they cannot identify the what type of the energy will be coming from out of the this transition. So that transition, that is called that is the name which will be named as a X-rays. X-ray, X means we cannot know, so that is called as a X-rays. That is the name of X-rays will be formed. So electromagnetic wave whose wavelength range from 0.12 and 100 Armstrong unit, that is the 10 power 10 meter scale. So this is the stature factor graph, that is nothing but the how much electrons how much of X-ray power will be developed by different type of material according to the electron density and electron probability of the crystal, that is the target material. So that is the graph to indicate that where is the how it is controlled, the energy will be controlled by the X-rays. So using the X-rays not the problem, it is the how much of electron energy will be produced, how much of X-rays having the energy, it will affect the what is the end user. So medical we can say that we can example we can say that we have medical using we are using soft X-rays will be a very low powered X-rays will be controlled by the how much potential giving to that source. So based on the source potential we have to control the output X-rays energy levels. So that is the main reason that is behind it. So they can see that right top bottom right bottom you can see that the first image of X-ray, that is nothing but William Roentgen's wife hand images. That is you can see that the golden ring intuited this was the first X-ray image will be captured by the William Roentgen of his wife, and you can see the golden ring, and that is a red and in that finger. So that is he discovered, that is taken at December 22 1895 at his laboratory, National Institute of Medicine. That will be very useful for that nowadays X-ray. We cannot replace the X-rays in those days. So this is the production of X-rays, how much is uh, developed. So it will be another one is the main is important, which will be used by the crystals. So X-rays only those days we have used for the medicinal applications. So in 1901 lava keeping the exposed by the crystals, it is called as a diffraction. This is the extraordinary possibility of determining the internal atomic of the crystal. So that it will be the one main discovery that will change the world, and by inviting these type of exposing these experiment will be opens the new way of the science, that is called as a crystallography. It will develop and it will mostly developed and it will be branches out of the various fields and will be used for various application nowadays. Without crystallography we cannot show modern instrumentation or the modern defects fabrications is not possible. So one of the main is 1921 Van Lowy exposing the X-rays on sodium chloride crystal that will be exposed a diffraction pattern. So it is image of the scientist, and it will be the one of the X-rays we have used in his laboratory. That is the original pattern will be X-ray crystal will be sodium chloride crystal exposed to the X-ray. That is the original diffracted image of the crystal structure. So that will be for that development. So further it will be X-rays will be exposed, that will be scientifically mathematically proven, and it is find out the how much is the atomic places, how much displacement places according to the lattice points will be identified by the two brothers, William Henry Bragg and William Lawrence Bragg. That is a W.H. Bragg family. The father and son, we have discovered the most important formula for identifying the atomic lattice of the crystals. Atomic parameters, that is nothing but the position of atom in the crystal, real crystals, given by the mathematical formula, that is sigma lambda n lambda equal to 2d sin theta. It will the main milestone of the finding the crystal lattice parameter of the crystal, that is the atomic orientation of the crystals. So that is the main important invention will be developed by the William Rogen and W.H. Bragg. That is the lambda is the wavelength of the X-ray. Theta is the angle, how much is the angle will be hitted on the surface, how much is diffracted. Diffracted means it is interference one to another. That is next one is the displacement of the disease. That is based on the diffraction spot and the position, we can calculate the d-spacing, that is the interplanar distance between the two lattice planes, that is the two atom line present in the symbol. That is the picture. You can see that incident line falling on that point will be indicated by the atomic positions or the group of atom positions. So it will reflected another incidence plane wave incident on the another displacement. The two lines are scattered or reflected to the atom present in the two different lattices. So it will be coincide at particular position, that is called as a diffraction position. So interference happen. So after the interference at particular point, how much this point is called, and the dot and flight fringes it produces consecutive interferences, and different interferences produce the dark spot on the plate, that will called as a diffraction spot. So it will be studied by this W.H. Bragg. So in this video we have stopped here about that X-rays and crystals. Next video we will see that application of the crystals in another video. Thank you.